is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
The universe is calling. Oh, I'm sorry, folks. This is Mark D'Antonio. Welcome to Sky Tour Radio here on KGRARadio.com. As you can tell, I like the theme song that Rebecca Borneman did for us. I'm your host, and I'm here with my ever wonderful co-host, Amanda Curran. Hello, Amanda. How are you?
Hi, Mark. Trying hard not to sing along with you. Love that song.
I had to stop because we were all
singing before the show started.
Yeah, and I also want to welcome Daryl Mason, who is joining us again. Hi, Daryl.
Hello, the universe is calling you.
We're the happy triumvirate, triumvirate of Sky Tour Radio here, folks, and we have a fun show, I think, in store for you tonight. And before we get going, I just want to mention a few things. If you haven't already, Sky Tour Radio is a wonderful KGRA radio show right here. You join us each week for 2 hours. And you can also join the companion stream to Sky Tour Radio, Sky Tour Live Stream. Sky Tour Live Stream is on YouTube. You can join us. It's free. And it's a clear night journey on the wonders of the deep sky. And we take you to these various places. We show them to you live with special cameras that show you things like you could just never see with your eyes. And also never see in a live stream before. This is all new. And this is kind of where we're going. And currently, the dome is in, and it's a real dome, is in picturesque northwestern Connecticut, but it's moving to Arizona. And since we spoke last, we have secured a place to put it in Arizona. So we are like bubbling over with excitement and just like anticipation. Can't wait to get it out there. And in Sky Tour Livestream, we show you things like remnants of dead and dying stars. We show you the glittering jewel boxes of rich star clusters. And we stream where you want to go. We take the telescope where you want to go too. Now, you can tell us what you want to see, and if it's up and we can see it, we'll steer the telescope toward it. We have a very active chat group. We encourage people to join the chat. And if you just want to lurk until you want to ask a question, then that's fine too, of course. And it's basically all proving that the Sky Tour livestream viewers, like the KGRA listeners, are the greatest audience and most knowledgeable audience on Earth, as it turns out. Lastly, our online store at fxmodels.com or at the FX Models Planetary Replicas page on Facebook is a place where you can go to purchase 3D printed Moon, Mars, and Pluto landscapes. And these are landscapes that are taken directly from NASA space probe data. So it's the real thing, guys. It's the real thing. We massage it into stuff that is a lot more real than the way a typical 3D printed thing comes out. And the way we do that is a company secret. But we do this because we want to do a beautiful product for all of you. Now, Sky Tour Radio has a call-in line. It's sponsored by the Paranormal app, and you can find that Paranormal app on Google Play and on iTunes. Or you can call 85-KGRA live when we open the lines. Currently, they are not open, but we will open them later on in the last half hour of the show. So that number will be put in the chat for you by one of us, hopefully Amanda or Daryl, because I actually don't have the chat up. I can't see the chat, unfortunately. So is that something you do, Amanda? I don't know if you can.
I can.
Awesome. See, folks, Amanda to the rescue.
Yay.
Yeah.
Mark,
And
you
Amanda,
know something we should talk about sometime?
all of us?
Oh, you and I at least, or on the show maybe sometime. Might make a good subject. If I was going to build a new observatory in Arizona, I would get me a great big telescope and put in that observatory.
You would, wouldn't you?
I would. You should.
Oh, he wants one. That is me. Okay. Yeah. telescopes are interesting, guys. You know, I'll tell you, and this is to all my KGRA friends and SkyTour livestream friends. Telescopes are a very interesting prospect when you want to go to the larger apertures, the larger diameters. They're much bigger light buckets, but what comes with them is a much higher maintenance schedule, and you got to be able to be in close proximity to it to take care of it on a more routine basis. Some telescopes can be remote and left for years that way, and they'll be fine. Me, I'm a little bit fussy about my equipment, and I would like to see, if the telescope's going to be a very large instrument out in the desert, like this one may be, I certainly want this thing to be well maintained, and especially in the desert where you have very, very fine particulate matter that is sand that's blown around from time to time. And there's places in Arizona where that does not happen. But the area we've secured is out in the Sonoran Desert, and it actually takes about an hour to get to off the main road. Okay, so and it actually has internet. It has internet and streaming capability, which is really fascinating. So that all said, if you want to join SkyTour livestream, please do. The Connecticut skies don't stop us from getting gorgeous photos. Just go to the Facebook SkyTour livestream with Mark D'Antonio and check it out, and you'll see all the pictures up there that we've taken, and you'll see some of the beautiful, beautiful images that we get here in Connecticut, all courtesy of this research-grade telescope that we've got cranking around in my front yard, by the way. It's in my front yard. There's a dome in my front yard, and everybody in town knows, hey, who's that weird guy with the dome? That'd be me. So, yeah, I know, right? So if you want to ask us any questions, give us a call or write us at skytourradio@kgraradio.com. That's SkyTour Radio, one word, one set of words, skytourradio@kgraradio.com. So tonight on SkyTour Radio, you know what we're going to talk about, Daryl and Amanda?
Origins of the moon?
Hey, you are smart. Where'd you come up with that?
I don't know. A little bird told me earlier today.
A little bird, like Mark D'Antonio. Yeah, actually.
And we might talk about a 3-for too later.
Oh, interesting. I would like to hear about that myself.
Well, you told me to talk about it, so get ready.
I know. But you're ready to talk about it, yeah?
Yeah.
Good, because I think it's really interesting, and I think it's a good idea. Fantastic. Okay, so we're also going to talk about exoplanets tonight as well, and there's a really cool exoplanet out there, and we're going to talk about it. It's probably the most incredibly inhospitable planet ever found to date. All right, and it was a planet that was discovered by the Wide Angle Search for Planets program. That's WASP. And they leave the F out, Wide Angle Search for Planets, because they don't want to say WASP, So it's WASP. And the planet is called WASP 121, which is the star, B. And you know how we use the letters to designate the planets in order of discovery. So WASP 121b is the planet. And WASP 121, the star, is a star that is an F6 star. Now, we know Amanda knows the stellar classifications, and we're going to ask her to do this. She's just come off a long week of doing an internet craze called Gish. So let's see if she remembers the stellar classifications, if she's even with us, because you know what? She could fall asleep at a moment's notice because she's been awake for a week straight. Isn't that true?
Gish almost killed me, but I think I can do it. I think it's been ingrained in my subconscious now.
Maybe so, huh?
I hope so. Is it OBAFGKM?
Yes, it is, and that's in order of.
O be a fine guy, kiss me.
Well, that's the mnemonic, yep. And
it's the spectral class. It's from the largest stars to the smallest stars, from the hottest to the coolest, and from the bluest to the reddest.
Very good.
Excellent.
Wow. Is that what you're looking for?
And then some. Daryl,
okay.
What do you give her for a grade on that, Daryl?
Yeah.
What do you give her for a grade?
Oh, A. She gets an A.
Hey. Oh, yay.
Hey,
She nailed it.
Yay.
Yeah, she did. Well, very good. Yeah, and this
I
one,
have a question before you get too far on this.
Yeah.
You said it was the most inhospitable planet
yeah,
that we found.
yeah.
Why are we, not we as in you, Daryl, and I, but why is that of interest? Like, if they know it's so inhospitable, are they, like, is this a test to see how we can make it hospitable? Is this, like, what's the point of gathering this information if we know, like, why wouldn't they just go, okay, it's inhospitable, next?
Move on, right?
Yeah, like, what
Well-
are we actually learning from
Well,
an inhospitable planet?
this
Can I pile on here for a second, Mark? Is this
Sure.
the same one that's so hot it's blowing metal off of it?
Yes, and that's what we're
Okay.
going to talk about.
Cool.
Which-
Okay, that's
so
kind of
special.
cool.
That's what makes it so special. See, here's the thing. Now you folks have to forgive Daryl and I for basically being little geeks who read all the astronomy news all over the place. He sends me articles, I read them. Sometimes I respond, sometimes I don't, but I read them all. And he's going to talk about one a little bit later, by the way. And this particular star, WASP 121, is a star that's kind of like the sun. It's a little hotter. It's, as Amanda went through the OBAF GKMs, she told you those are the spectral classes. That indeed is true. Well, F comes before G. We're a G-type star. F is a little bit hotter. It's an F6, and then it's a normal star that's fusing hydrogen into helium. And the F6 star is actually it's stable, but it's very much more hot than the sun. So it's 850 light years away from us here on the Earth, and the planet that's circling it, 121b, is going only 0.0254 astronomical units from the star. Now, what does that mean? We are 93 million miles from the sun, 1 astronomical unit. This planet is basically 2.3 million miles from the sun. That's 3.8 million kilometers. All right. So it's 16 times closer to its star than Mercury is to our sun. All right. And Mercury averages about 38 million miles. Okay. 61 million kilometers. And at that distance, Mercury's surface can melt lead, which is a fairly low temperature metal. But this planet is 16 times closer to a hotter star. Yet it has survived. This planet has survived. This alone is a feat in and of itself. But that's not the most incredible thing. As Daryl alluded to, 121b is also hot enough to melt iron and magnesium on the surface. But beyond that, these elements boil, leave the surface, boil and evaporate off the surface and go into the atmosphere. Now, these aren't the first planets to have that happen. That happens on other exoplanets too. But those planets usually, as the iron leaves the surface, it actually forms clouds. So you get iron clouds. And these iron clouds effectively are the end state for the material once it's in the atmosphere. It stays, though, with the planet. This iron, though, it's so hot. What happens is the iron is going up into the stratosphere of this planet's atmosphere. We see this in its spectra because we're seeing the atmosphere of the planet 800 plus light years away. And the iron, for instance, is actually leaving the planet. And you can see the trail of iron in space behind the planet as it moves through the orbit. And magnesium. Now this is new. This is something new. And what happens when the iron gets up into the atmosphere, it also prevents the ultraviolet light of the star from getting through. So you might say, oh, well, that's good. So if you don't get the UV through, then maybe the hot radiation, that highly energetic radiation, can't affect anything. But it does. The UV from the star transfers that energy from one type of energy to another type of energy. That ultraviolet light hits these iron molecules and magnesium molecules, and it's converted to heat. So the upper atmosphere is superheated, thousands of degrees. It's all probably incandescent. And the iron and the magnesium actually escape into space. And it's the first time we've seen a planet that's venting these heavy elements into space like this. Now, with this kind of scorching heat, you might think it's got to be dry as a bone. There can't be anything there. There's probably no water. But in fact, because of the special conditions at this planet, there is water there. There's water molecules that are still present in this atmosphere, believe it or not. And these water molecules are what they call hot water molecules, stands to reason. All right. And these exist under, like I said, certain conditions in this incredibly inhospitable world. So I just want to say, let's not go there and not even say we did, okay? I think that's a pretty incredible thing. Now, Daryl, you read the story on this. You know this is a planet that's like, it's not very different from other planets we've seen. There are other planets that are closer to the star. This one has also got a weird shape. It's actually shaped like a football in a sense. It's very oblate at its equator. And the reason has to do with the fact that it's so close to the star that the tidal forces are just at the edge of ripping the planet apart. And the tidal forces aren't at that point where they can rip it apart. It's right at that Roche limit, basically, just about. And that's the limit at which a planet could withstand the gravitational differential from one side to the other, but because it's so close to the planet. And that's why, for instance, Saturn's rings never congealed into planets or moons, because the differential gravitational force acting on anything trying to form would tend to, on the near side towards Saturn, pull it apart from the stuff on the far side of the moonlet that was trying to form. And so we never even begin to get a moon there. If it's tiny, it could exist, like the shepherd moons exist within the rings. But that's about it. There's nothing else we can get. So that's
the Roche limit. That's also what dooms the moon Phobos around Mars, isn't it? One of the moons, Phobos or Deimos.
Yeah, as soon as you enter the Roche limit, it's going to get torn apart. And Phobos and Deimos, interestingly, on the SkyTour live stream last night, we actually did a SkyTour live stream using the most realistic and beautiful universe simulation product ever. And it's not Universe Sandbox, which is what we used in the past. This one is called Space Engine. And I got the paid version because it's beautiful. And it really shows you the most amazing views of the universe. Now, you can get the free version. There's a free version. It's not as detailed, doesn't have as much information. It's a little more clumsy. The new one is extremely slick, and you'll like it. But we actually were visiting Phobos and Deimos last night, and I was driving people around and navigating as if I was the captain of the ship, so to speak. But I wasn't talking like William Shatner because I'm not William Shatner. So, so basically, it's a beautiful product to try that out. And so Phobos, when Phobos orbit decays, it's going to enter that Roche limit, and then Mars may eventually have a little ring around it. And if those little pieces of debris enter the Martian atmosphere, they'll probably 9 times out of 10, most of them will strike the surface because there's not a very large atmosphere, and so it'll manage to get through. The atmospheric pressure here, for instance, on the Earth is 1 atmosphere, which is 1,000 millibars. On Mars, it's 6 millibars. So there's not a whole lot of atmosphere to stop things coming in, which is why you see so many craters on Mars anyway. So the atmosphere on Mars was denuded of anything heavier than the carbon dioxide and more numerous than those molecules a long time ago, through all of the ultraviolet radiation striking the surface and breaking up molecules that are important to make Mars have a heavier atmosphere. And then that's unfortunate, but and so forth. But as we've talked about in the past, we know that for planets like Mars, we know how to terraform them now without even touching them. And Amanda knows too, because we've talked about this. She has I like her term for it. You remember your term for the
space blanket?
Yeah, it's like a blanket, right?
Yeah.
It's actually creating a magnetic field away from Mars, but in the direction of the sun at a point called a Lagrange point, which is like a parking spot in space, where all of the forces around it, of gravity sum to zero, basically. And you can actually create a large magnetic field out there. And when the solar energy, the solar particles strike the magnetic field, then there's a tendency for that magnetic field to drape behind the generator of the magnetic field. And if what's behind the generator of that magnetic field is Mars, then Mars could be encircled by a fake magnetic field. But the molecules on Mars that are escaping all the time, carbon dioxide, water, other important molecules, oxygen even, through other processes, wouldn't be depleted from the atmosphere. So it would be the kind of thing where Mars could, over time, terraform itself, because its natural processes, albeit they're slow, would actually cause a difference in the atmosphere. And within a few years, we'd actually see a difference. Within a human lifetime, you'd see a difference to Mars. And it would become like, oh, hey, let's go to Mars tomorrow. It wouldn't be like beautiful blue sky and things like that. But the atmosphere would start to build up. And we would notice that, probably in the form of fogs and clouds, hazes. The Martian surface might actually have some type of weather induced by the terrain or whatever, clouds near a hilltop or whatever. So we might see something like that. So it's pretty cool. So I think that's a project that's it's sort of on the NASA docket. We've talked about it before. Amanda calls it the Mars blanket.
What do you call it?
Well, it's just a terraforming process for Mars where we don't even have to touch Mars.
No, I know, but I thought you called it something different. I called it a Mars blanket, and you called it something else. It wasn't just a magnetic field. I thought you had a term for it too, and for some reason I confused it with blanket. No, maybe not.
I don't remember what I might have called it, other than a terraforming process for Mars where we don't have to touch it. But that's kind of wordy. I might have had some clever little quip, but I don't remember it. I'm not always a clever person. Sometimes I am in very rare instances.
Well, I'm glad you guys know what I mean when I say things like space blanket.
Oh, sure. Yeah. I do. Daryl does.
Yeah, I think Daryl does too, yeah.
And so does everybody listening. We all understand.
Wonderful.
So, yeah. So, I think that it's pretty cool. And I want to go through a little news note here that's important. The NASA's Curiosity rover has been tooling around on Mars since 2012. It hasn't died yet. The Curiosity rover is a rover that it's basically the Mars Science Laboratory. It's the most elaborate science laboratory ever placed on Mars, and it's all in one rolling bundle. So when Curiosity discovered something that had been absent from Mars, but that had been seen before on Mars, it turned out that this was something that scientists stood up and took notice of. And do you or Daryl know what that was that Curiosity saw? It's a little quiz. It's still your turn.
That something that Curiosity found?
Yes. That was seen before. And people in the audience are saying it right now. I can almost hear them saying it. Daryl, do you know?
I'm drawing a blank here.
Okay. Then that's good. I shall tell you.
Was it a crater?
No, not a crater.
Eric has a guess.
Marvin?
Cute.
Marvin the Martian?
Us Martians get very angry indeed. Yes.
Eric's wondering if it's a volcano.
No, but volcanoes do spew some of this.
Lava?
Yes, but that's not it. It's a gas.
Oh, methane.
You got it. That's right.
I was waiting. I'm like, okay, that's the clue that's going to tip Daryl over.
Yeah. See, Mars had a methane bloom some years ago, and it was seen during the Martian summer, so they thought, ooh, maybe these are microbes that are causing this. Now, that said, these microbes would have, in the summertime, maybe rejuvenated, come to life, bloomed a little bit, kind of like the bacteria bloom at the oil spill in the Gulf, and cleaned up the Gulf basically in record time compared to what other people were saying. The doomsayers said it was going to kill the Gulf. Within 3 months or 4 months, most of the methane in the water was gone. And it was because there were methane-eating bacteria that bloomed. So they thought maybe there were microbes that were emitting methane that were up on the existent under the ground. And so Curiosity found another methane bloom, and it was much, much higher in concentration than the last bloom that was seen from space. So Curiosity is still showing us curiosities of Mars. And so our knowledge, our thirst for knowledge, is still being satisfied by this 1-ton rover on Mars. It weighs 1 ton. Can you believe that? That's on Earth.
It's the size of a piano.
Yeah, and it's a big one. It's a big boy, you know. But we will talk about that and more. I have another news note for you too when we get back, which will be really cool to talk about.
KJRA has a few news notes for us first.
Oh, they do?
With their commercials.
That's right. That's right. Well, folks, we'll be right back after these words here on Sky Tour Radio from Daryl and Amanda. We'll see you on the other side.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now. The Paranormal Radio app. Free in Google Play and the iOS App Store.
Hey, is that a new music app?
Yeah, check it out. Surfer Music Discovery. It links to thousands of online stations, but the twist is you see the song names and artists that are now playing live.
That's different. No guessing. Looks like a waterfall of music.
So many formats. Rock, oldies, country, R&B, jazz, and a whole lot more.
How's that spelled?
Surfer. S-U-R-F-R.
Is it expensive?
It's free. No need to sign up or sign in.
Get the Surfer Music app free from Google Play or the App Store.
Folks, this is very important information. What's to be said about CBD? AncientLifeOil.com. Our CBD is made from hemp and has 0.003 THC, which means this wonderful product won't get you high, no matter what amount you take. What does CBD do for the body? My hands are tied. But you can Google CBD benefits and be astounded. When you're finished reading, you'll want to log on to AncientLifeOil.com. That's AncientLifeOil.com and purchase. Life is good when you feel good. People are tired of pain. People are asking for non-GMO organic products to help them with, you fill in the blank. Legal in 49 states, and again, our CBD is made from hemp. Ancient Life Oil is about helping people one by one by one. If you wonder how good the product is, the CEO takes it every day without miss. AncientLifeOil.com. That's AncientLifeOil.com. Have a great day.
Where will you be this September 13th through the 15th if you are a critical thinker seeking answers to questions like, what are aliens? Are they demons or visitors from other worlds? Do they have an agenda? And if so, how do we stop them from interfering in our lives? Then the place you need to be is Branson, Missouri, inside the Mansion Theater, as Gen 6 Productions presents The True Legends Answering the Alien Question Conference 2019, featuring writer, explorer, and filmmaker Timothy Alberino, author, lecturer, and filmmaker L.A. Marzulli. Is our planet being prepared for reseeding by non-Earth entities? Find out from publisher Mike Adams, UFO investigator Chase Kletzky, investigative reporter George Knapp, world-renowned researcher and author Steve Quayle, and many more. Reserve your seats or order live streaming now at gen6.com.
Mainstream media's most wanted. KGRAradio.com.
Hey, welcome back to Sky Tour Radio. This is Mark D'Antonio, at least that's who I think I am. And I have Daryl Mason and Amanda Curran with us tonight. They are the ever-present co-hosts and co-hosts of SkyTour Radio. And we had a news note that I wanted to bring to your attention. And I also have another one, but I want to let Daryl tell you about this other news note, which is absolutely fascinating. And it has to do with those amazing detectors that we have heard about before. Daryl, you want to carry this one?
Sure. Amanda, feel free to post that link if you like, please.
Sure.
This is an article I came across a few days ago, and I forwarded to Mark. I just thought it was fascinating. This relates to the LIGO and the Virgo gravitational wave detectors. You might have remembered making the big splash. Golly, has it been 2 years, 2017, when the two neutron stars collided? Well, they are presently doing a new run with the LIGO detector. It's been upgraded, and they're getting some amazing results back from it. Ever since that neutron star collision happened, it's kind of fallen off the radar, but LIGO is still out there doing good work. This article is from Forbes magazine, of all places, which you'd think would be talking about business, but this is one of the best things I've read in a long time. I highly recommend you study it. They are looking at getting the trifecta, getting signals across three totally different regimens of detection that we can do during doing astrophysics. Traditionally, we've used the electromagnetic spectrum, think visible light for telescopes, but then there's also on the high long wavelength, low frequency and low energy, you've got radio, you've got infrared, you've got visible, and then moving up into the shorter wavelength, higher energy stuff in ultraviolet, getting up to X-rays, and ultimately, I guess, maybe gamma rays, that we have traditionally detected astronomical events and studied astronomical phenomena, astrophysical phenomena. Well, now they are looking at being able to do this in three different, totally different regimens of astrophysics, not just electromagnetic spectrum, but also particles and now gravitational waves. And what this trifecta is going to be, they actually did when the neutron star collision happened a while back. You might remember, not only did they detect gravitational waves, they detected a electromagnetic component over time after the event. That is, they saw it in various wavelengths of, let's call it light, for want of a better word. And that taught them a lot. Now, the guys doing the LIGO detector, they are getting really good, really fast, especially here since they brought it back online in April, that results are coming in hot and heavy. And they're learning really fast from what they're studying and what they're discovering, that they can quantify what's happening much better than they used to. You know, they're getting better physical descriptions of what they're seeing and what it means. Ultimately, they're looking for a third regimen. Now, you have electromagnetic spectrum, you have particles, and now you have gravitational waves, and they're looking to combine all three. This will be revolutionary. This is a landmark. Just seeing it in two regimens was a landmark, and now they're looking at a third. There was an event LIGO detected back on July 28th, 2019, that they detected particles along with a gravitational event happened. This was at one of the big neutrino detectors that they saw this gravitational event occur, and pretty much simultaneously, one of the big neutrino detectors had a neutrino detection event. Now, neutrinos are special. Neutrinos are at the far end of like particle physics. As you sit there listening or whatever you're doing, there are billions of neutrinos sleeting right through you, right through every square inch of you every second. Billions of them.
That's
now,
a good way to put it, too. Sleeting.
Yes.
Good way.
Neutrinos are notoriously difficult to detect, but they do have ways. They will occasionally detect some when a relevant kind of event happens, a supernova or something. That these big detectors, I'm not going to go into it in depth, but they have come up with ways to detect the occasional neutrino. Out of billions per second, they see a few, okay, when something cool happens. And on July 28th, 2019, they observed what they believed to be two rather large mass black holes collide, and it made the gravitational waves that LIGO detected. But at the same time, this neutrino detector detected neutrinos, and they plotted both of them on a chart of the sky, and they're coming from the same place. Okay, so now all we need is an event where we get a electromagnetic component as well, and we will have seen it across three totally separate kinds of astrophysics.
And that's by the trifecta.
Yes, and thus the trifecta. And, well, this is because science, but the things we could learn from this. Okay, ultimately, it's we're really far down on the learning curve right now, but we're learning more and more really fast. And I think possible ramifications of this could be huge. This opens up whole new windows into how we look at the universe and what's happening around us. In a nutshell, I think that's it. I highly recommend you go read that article. It is an really excellent article.
Yeah, it is. It is. And if anybody has any questions about it, you can write us here at SkyTour Radio at kgraradio.com. We'll be happy to answer questions you may have about it. In a similar news event, you might recall the imaging of the black hole 55 million light years away in the M87, Messier 87 Virgo galaxy. It's a gigantic elliptical galaxy, round galaxy, and it actually has this radio jet of material that's coursing out of it at high speed. And the Event Horizon Telescope was able to image the source of this large radio jet, and you saw it some time ago. It was the black hole in the center of that galaxy. A black hole that's several times bigger than our entire solar system in size. And that imaging technique with that Event Horizon Telescope utilized the entire Earth as a telescope. So the Earth itself, as it rotated, different instruments on the Earth looked at the Virgo galaxy and looked at this area and imaged it for as long as it could. And they combined all of the information together and effectively made a telescope that was 8,000 miles in diameter, which is the diameter of the Earth, 7,900 miles, but who's counting? And so that process is now being turned toward our own galaxy. And Sagittarius A, as predicted, is being. I predicted this, and I'm sure that it was already on the books. They just chose M87 to do this the first time. They're now looking at what we call SAG-A, and they're going to get an image of our black hole here in our own galaxy.
Cool.
Yeah, and if you look online and you look up stars orbiting our black hole, I know that sounds crazy, but if you look that up, you'll see a video that was a 10-year-long video that shows a continued effort to map the star movements around this black hole in the center of our galaxy. And you can actually watch the stars whipping around the black hole. I can actually show this dynamically in this product I talked about earlier, Space Engine. You can actually see the SAG-A stars and go all around them and actually be part of the whole process. It's very cool. And so Event Horizon Telescope is going to be used again, and this time here on our home front with our own black hole and our own galaxy. Isn't that great?
That is. I can hardly wait.
yeah. I can't imagine. It's going to take a while because they're going to have to get all the telescopes online to look as best they could in the Sagittarius A direction. But we have a narrow window that we could look through and see as far as we can toward the center of our galaxy. It'll be really cool. And even have a third news note tonight, Darrow. This is kind of odd. I don't have news notes very often, but these things came in very fast and furious. And I think, speaking of fast and furious, this last news note is one that has to do with fast radio bursts. You may recall we did a Sky Tour Radio about fast radio bursts, affectionately known as FRBs. And when we did this FRB discussion, we talked about what they are. We talked about where they seem to come from. We talked about how the fact that they are these very, very high frequency bursts that last only a millisecond or two, a few milliseconds, and then they taper away and go away. And we didn't know where they were coming from. They seem to be one-time events. Well, since then, we've discovered they're actually repeating events in some cases that seem to be coming from the same place more than once. And it was perplexing everybody as to what might have been causing this. There were the typical thoughts that were, well, it's an alien civilization signaling us, which I never believed for a minute, and I'll tell you why. I think that using light speed to signal someone at a very, very long distance is really not a very clever idea, because light is really it's the fastest thing in the universe, but it's very slow when you're trying to get anywhere. Okay, for instance, when Mars is that closest approach to us, it takes the light signals which is what radio is, the light signals, the radio waves that instruct the Curiosity rover and Opportunity rovers when they were active, when the Opportunity was active, to do things. It took 4 minutes at the shortest time for the light to get there, for the signal to get there, and as long as 20 minutes plus when we're on the opposite side of the sun from Mars. So even in our own solar system, light is too slow when it comes to certain types of signaling. But the fast radio bursts seem to be coming from billions of light years away. Billions of light years away. And they were very powerful. Now, here's the thing about light, which I've explained before, but I'll tell you again. Light intensity drops by the square of the distance away. So when something gets 4 times further away, the light energy is 16 times fainter. 4 times 4 is 16. And it goes on and on. Well, how faint would the signal be from billions of light years away? In other words, how strong would that signal have to have been at the source for that signal to be visible billions of light years away?
Exactly.
And the answer is stupendously, colossally, unimaginably huge. And so these fast radio bursts lasting only milliseconds were just incredible, and we didn't know what they were. They still didn't. And there's a tenuous theory out there now, which I'm going to relate to you. And they start off when you see a fast radio burst, they come in as a real high frequency, blip, right, way up in the upper gigahertz range. Okay, and radio, for instance, is in the megahertz range. You have some gigahertz transmissions, but gigahertz is very, very high energy, right? And then the fast radio bursts inexplicably would drop down in frequency. In other words, they'd go from a high frequency, many gigahertz, down to a lower frequency in the lower gigahertz range. Now, why is that important? It shows that something is causing these things to drop in frequency. And when we see that as astronomers and other people that are in science, when we see the frequency shifting, it means to us that there's an active process causing the frequency to change, right? For instance, when you see lightning from a very, very long distance away, it kind of looks orangey and reddish sometimes. And when the streak is close to you, it looks blue. So the higher energy when it's nearby, when you see it from a longer distance away, some of that energy is getting absorbed by the atmosphere, and it's being reddened by the air between us and the lightning bolt. So it'll look a little bit more red. All right. And so the fast radio bursts are doing that at the source. In other words, if you were close to it, you would see a very, very high energy pulse, and then it would drop to a lower energy, before the end of it, right in front of you, right at the very source. So it's very different from, say, how lightning would operate. So what's going on here? Well, a team was looking at this and has been looking at this, and they didn't know where to go with this until one guy, a guy named Metzger, he was looking at this tapering of frequency from these fast radio bursts, and he thought, I've seen this before. I've seen this before with high energy tests. Where did I see it? Aha! I saw it when we did nuclear tests. When we were experimenting with that ignominious science of nuclear weaponry, we actually noticed that when the blast wave would first, in these nuclear test detonations, the intense radiation would move out from ground zero, and it would sweep up more gas along the way, more atmosphere, as the blast expands. Now, the cost of sweeping up that gas is that the blast radiation is slowed down and restricted from moving out at the same energy levels. And in terms of light, it would get Doppler shifted downward to these longer wavelengths. When you lose energy with light, it goes to a longer wavelength. And that's what was seen with these with these nuclear tests. So in the extreme case, that would be like going from a highly energetic blue light to a lazy long wavelength red light. So this is kind of what we see with the fast radio burst, all in milliseconds. Astronomers notice the same type of this energy shifting, but of course at a much more massively high energy level. Now, this led to a theory that the fast radio bursts are the result of a similar outburst of some kind from a special kind of star. And it turns out that it might be a neutron star that has a especially high magnetic field, one we know to exist. It's called a magnetar. Now, magnetars are really places you would not want to go. If you were anywhere near a magnetar, it would literally rip you apart cell by cell just from its magnetic field. If you think an MRI machine is bad, just get a magnetar, which is millions and possibly billions of times more energetic. You'd be ripped to pieces. So when a magnetar releases this wave of energy, it releases a high energy flare. That's how a FRB, a fast radio burst, begins. It releases a high energy flare by any other name. And as that released energy in the form of high energy electrons hits the previously expelled flares that are always coming off of the magnetar, then what happens is these previously emitted flares are already moving slower because of their collisions with other things in the interstellar medium. And as the new material hits these old flares, it begins to excite. This new material begins to excite the old material, and the new material begins to cause its electrons to go into this weird cascading motion and energy levels, which causes this release of the FRB radio pulse. And once that happens, the FRB, the fast radio burst, that new burst that came off that started with a flare on the magnetar, that new energy is sapped by this collision with the old material, and its frequency drops and shifts downward, which is what we see. And this is in the Doppler shift. So the blue light, basically higher energy, and it drops to the less blue light. But in terms of understanding how the energy goes, it basically goes from the blue high energy toward the red, a little bit lower. So we see these FRBs go from a blue state to a more red state, and that's one of the things that really fits nicely with the observations, is the predictions. So this new theory holds promise, but it still has to be tested. But fast radio bursts, we're beginning to understand the mystery. We'll have it figured out someday.
And you said that they have now detected multiple pulses from the same location.
Yeah.
So the object is surviving the blast or whatever.
Right, and that would be consistent with magnetars that are releasing huge pulses or flares. And I can't imagine the area around these magnetars. Magnetars are neutron stars. Neutron stars are the result of supernovae. So where the supernova was, these stars that were very massive, but not massive enough to form a black hole, will form a magnetar. The problem is, and there are still some mysteries, these magnetars have to be massive enough such that they would become black holes. but they're not. So that's a mystery we have to figure out, but we don't have all the answers yet. And that's the collective we. I don't research magnetars myself, but I research exoplanets. That's me. But I don't do magnetars. But you know what? You have to understand all these things, I think, in part, to move forward with the understanding of the universe. There's so many things that are changing in the universe as we speak, and it's just amazing. Like I said, the theory holds promise, but it still needs some more testing, more data, and guess what? More fast radio bursts. I could use a few myself. I'd like to see that. Now I want to go on. Let's see. We're approaching. It's like almost 10 to 9, and we're only now getting to our main event. But that's okay. Our main event is one that we can have some fun with, and whatever we don't get done, we'll move on and bring next time, next Sunday perhaps. And now I told both of you what we're going to do. Do you remember what I said we're going to do tonight?
Origins of the moon or something like that?
Yeah. And lunar origins and mysteries thereof and surrounding the moon. There's a lot of things about the moon that we've talked about in the past, but these things we're talking about tonight are things we have not talked about in the past. These are things that we didn't conveniently avoid. We just didn't talk about them. But what I do is I would like to talk about them tonight. And here's where it goes. The basic observations that we have when we look at the moon is that it's large in comparison to other planet and moon ratios. People say, well, why is the moon so large? It's got to be artificial. It's got to be this. It's got to be that. Well, Ganymede is the largest moon in the entire solar system. It should actually be a planet. It's 3,270 miles in diameter, which is 5,200 roughly kilometers in diameter. But compared to Jupiter, which is 86,000 miles in diameter, or 142K in kilometers, 142,000 kilometers, Ganymede's 26 times smaller than Jupiter. So you can see that there is a relational system there where the moon, large as it is still dwarfed by the main planet. Here, though, it's a little different. The moon is considered monstrous compared to the Earth in some ways. The moon's just under a third of our diameter. Now, why is that? And we'll answer that tonight. And it also appears, there's another mystery, it also appears to be exactly the size of the sun in the sky. Why is that?
Mm-hmm.
Yeah, we can answer that. And the moon's orbit is inclined at 5 degrees to the plane of the solar system in Earth's orbit. Now, if it wasn't, we would have eclipses every single month.
Yep.
So why is it inclined like this? Daryl mentioned this some months ago when we talked about this. He actually mentioned when we were talking about the moon, he mentioned that we talked about the orbit of the moon and how we don't get eclipses each and every month. But we would have them if it was actually in the plane of our orbit with the sun. So why don't we have that? That's something interesting to talk about. And we haven't talked about any of these questions. And we're going to answer them one by one as we move forward. And I think it's important to understand that to answer these questions, we have to go back to the beginning. We have to go back to when the solar system first formed. And so we're going to go back to that point. All right. Now, it's going to take us about 4.6 billion years. So hopefully we'll have electricity in the far future, in the distant past, I should say, as we go back in time here. But I'm sure we will.
I hope there's plenty of toilet paper, too.
And what Daryl's referring to there is a funny thing that I'll be doing in Norway. Actually, I'm leaving for Norway on the 14th of August, and I'll be back on the 31st. And I'm doing a speaking tour over there, which will include toilet paper.
Are you going to have to unroll it the other way?
No, I wouldn't have to unroll it the other way.
And what is Norwegian customs going to say when you try to bring a roll of toilet paper through our toilet paper not good enough for you Americans?
I haven't thought of that. Mine has writing on it. Does yours? What Daryl's referring to, of course, is the fact that I have the entire Earth history that I put on a roll of toilet paper to illustrate in a very visual way how events transpired on the Earth from the very first moment that cyanobacteria, those oxygen spewing carbon dioxide gobblers first appeared on the Earth over 3 billion years ago, to when dinosaurs roamed the Earth, to when we roamed the Earth, and how all of these times that we look at, a timeline of history, everything takes place in such a way as there was a vast acceleration of life right near the place where we are today. And when we look at this whole scale, it's over 100 feet long. And literally in the last 2 feet, there's things happening all along the way, but in the last 2 feet is where things explode. And in that explosion, that's where dinosaurs rose and fell. And that's where when they went extinct, that was 18 inches from where the end would be. Okay, so you can see, for instance, that dinosaurs, right off the bat, that dinosaurs are now recent history on this planet, not ancient history. It's ancient to the human way of thinking, but not as far as the planet's concerned. And when we talk about the moon and the changes the moon has gone through, and these 3 things, which we'll review after the break, then you'll see how all these changes to our solar system have occurred, and you'll understand a little bit more about the moon. But we'll have that and more when we come back on SkyTour Radio. I'm Mark D'Antonio with Daryl and Amanda, and we'll be right back.
Hi, this is Matt Ray for MySleepAllNight.com, and most of us don't even realize that almost all of the healing, learning, and rejuvenating that happens in our body happens only when we are deeply asleep. Now, if you have trouble falling asleep and staying asleep, it's likely you never consistently achieve that crucial level of deep sleep. Deep restorative sleep is the key to health, mood, productivity, longevity, memory, you name it. So many health benefits. To experience what deep sleep feels like, try the new dietary supplement Sleep All Night, formulated by scientist Kurt Hendricks. And sleep like your life depends on it, because, let's be honest, it does. Head on over to MySleepAllNight.com. That's MySleepAllNight.com. Enter the promo code RADIO for 20% off your purchase. Again, head on over to MySleepAllNight.com. Enter the promo code RADIO. That's MySleepAllNight.com. Hi, Matt Ray with America's First News here, and I have great news for those of you who suffer with debilitating migraine headaches, maybe a loved one or your child does. MigraLief, the nutritional migraine supplement everyone's talking about, now can be found at the vitamin shop stores nationwide and Meijer in the Midwest. For almost 2 decades, hundreds of thousands of migraine sufferers have benefited from MigraLief, and thousands of neurologists and headache specialists recommend it. Why is it popular? It's drug-free and addresses the specific nutritional needs of adults and children who suffer migraines. What's even better, MigraLief comes in a formula you can take daily and one on the spot as needed. So if you get migraines, get your life back on track. Go to MIG911.com. That's MIG and the numbers 911.com. That's also where you can read the testimonials. Or head on over to your local vitamin shop store nationwide or Meijer in the Midwest. If you get migraines, do yourself a favor. Change your life with MigraLief.
Get a KGRA discount to the 2019 International UFO Congress. When you register at UFOcongress.com, enter code KGRA for 10% off. Go to UFOcongress.com, enter KGRA at checkout, get 10% off. It's that easy. Visit UFOcongress.com for more information about the most anticipated UFO event of the year.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now. The Paranormal Radio app. Free in Google Play and the iOS App Store.
Hey everyone, this is Nick Redfern and you're listening to SkyTour Radio with Mark D'Antonio on the KGRA network, and so are the Men in Black.
Now you have the inside contact for alternative talk radio. The Planet. KGRARadio.com.
Hello and welcome back to SkyTour Radio here on KGRARadio.com. This is Mark D'Antonio, as ever, your host for SkyTour Radio, here with Amanda and here with Daryl. Now, before the break, we talked about Lunar. We talked about the moon and the strange oddities of the moon and the situation we have with our moon. Now, we talked about there's different qualities of the moon, characteristics of the moon that have been perplexing us, things we've never talked about before. And we talked about how the moon is large in comparison to other planet and moon ratios. Ganymede is the largest moon in the solar system, as we said. And, Earth's moon, or the Mun, if you play Kerbal Space Program, is 2,160 miles across. And compared to Earth's diameter, the moon is, we said, monstrous at just under a third of the Earth's diameter. And so that brought up a question of, why is this? And we talked about the sun and the moon seem to be the same size in the sky. Why is this? And the moon's orbit is inclined at 5 degrees to the plane of the solar system and the Earth's orbit. Why is this? This is something that is somewhat unique to the Earth moon relative to other moons in the solar system, although other moons have wacky inclinations as well. But why is ours inclined like this? Well, on previous SkyTour radios, we haven't talked about those, so let's take them one at a time, as I said. So the question is, why is the moon appear so large? Okay, why is it so large, of a body? Okay, and this goes back to the formation of the solar system and what we call the nebular hypothesis. Now, the nebular hypothesis is the hypothesis that most of the planets, if not all, and their moons formed by accretion, which is the gradual self-gravitational forces that cause clumping of objects in the disk around the sun, disk of material around the sun. Think of the disk of material around the sun as the raw materials from which planets and moons are made. And you can expect that some of these materials would over time clump together, and 2 will attract a third, and a third will attract a fourth, et cetera, until we have planets and moons. All right. And the other thing that occurred, which is really strange, is the outer planets, okay, Jupiter, Saturn, Uranus, and Neptune, actually formed closer to each other and closer to the inner solar system, but migrated outward and back in a few times over the many hundreds of millions of years and billions of years during the formation, during the life of the solar system. And how do we know that? Well, we know that because there's discrepancies, for instance, in the size of Mars. Mars? Yeah, Mars. When we look at Mars, for instance, we think that based on the material that we surmise was available to it, Mars should be bigger, larger, possibly, a much larger planet than it is now. And the data shows that Jupiter had actually migrated through gravitational interactions long-term to a little bit closer to where Mars is. And as Jupiter was forming, it robbed the young Mars of material that it might have used to grow larger. Then Jupiter migrated outward again. And we call this planetary migration, and it's something that you can actually look up and see and learn about. And then Jupiter moved outward again to its present position. Jupiter also affected the asteroid belt greatly. Originally, the asteroid belt had enough material in it to form like 2 to 3 Earths. 2 to 3. All right. And instead, as Jupiter was migrating back and forth, it absorbed some of the material. It ejected some of the material from the solar system entirely, because it is, next to the sun, the most powerful gravitational forces that the other planets feel. And when that happened, the asteroid belt was gradually diminished to its present size. Now, Uranus and Neptune, when we look at them, in the world of planetary science, when you study how Uranus and Neptune are formed and the amount of material that's contained in these fairly large planets, they could not have formed where they are. They had to form closer to Jupiter and Saturn for them to even be able to exist. And so they migrated outward over time. And this is based on studies of the compositions and the projected availability of materials early in the solar system history. And jumping back to that asteroid belt for a minute, Jupiter caused these disturbances to the orbits of the asteroids. It also prevented the asteroids from forming larger planets and larger planetoids and planetesimals. They did form, but Jupiter, from what we see, destroyed them with its orbit and with its gravity and the migration that it carried out throughout its migrational history. Now here we are, sitting on the Earth, way in the inner solar system, and we're here the entire time, but we're not immune to the chaos in the outer solar system, because things that are disrupted out in the outer solar system will then be attracted by the next largest gravitational force, the sun. And so everything that's thrown away from Jupiter's gravitational force will get tossed and pulled toward the sun. So as Jupiter migrated toward the asteroid belt, its gravity perturbed countless asteroids, and these made their way to the inner solar system, and many of them collided with the Earth, very likely. This is actually known as the late heavy bombardment era, and it happened around 4 billion years ago here. Now, it's around this time that the Earth was also struck by one of those planetesimals dislodged by Jupiter. And that is a Mars-sized body that has been theorized to have struck the Earth, and thus the Earth and this body collided. They melded together. A big chunk of it blew off the Earth and ended up in an orbit around the Earth, and we call it the moon now. So it may have been a ring-type material around the Earth that coalesced over time into the moon, or it might have been one giant blob. We just don't know. But listen, this is interesting. After that bombardment era, the earliest life on Earth recorded was around 3.8 billion years ago. Now think about that. So life found a way, even after all that, to come about fairly quickly on this planet. So I have a theory, and it's kind of the premise of the book I wrote called The Populated Universe. And that theory is that the planet Earth has life because that's the rule, not the exception. And I think the universe basically fosters life through an elaborate series of templates that are natural templates. The carbon atom, for instance, is an atom which is very prevalent, number 8 in the periodic table. It's also an element which has more bond capabilities with other elements than any other element in the periodic table. We've talked about it before. It's the grandfather of all elements, essentially. The one that is, the biggest source of life. So we think that life that's carbon-based kind of makes sense. So I'm kind of a carbon bigot. I've said that before, and I accept the moniker. Okay. And the carbon-based materials that were delivered here came to us from the heavy bombardment era we talked about, and that's where a lot of the water came from as well, because asteroids brought a lot of water here, as probably more so than where it was created by the Earth's processes itself or delivered by comets to the Earth. Originally, we thought comets gave all the water to us, but you know what? That was kind of myopic and short-sighted, and really the asteroids actually have a lot of water in their chemistry. Look at the moon, okay? We thought there was just water near the permanently shadowed craters at the poles of the moon. It turns out that throughout the moon, there is water, bound up in various forms in a lot of the lunar soils all over the place. So we're learning a lot about this universe. It takes us a little while. So the bulk of the water we have came from the processes like that and from the heavy bombardment era about 4 billion years ago. Meanwhile, as Jupiter migrated back and forth, the asteroids were depleted, like I said, to the level at which they are today, which basically couldn't even make up a fourth of the moon when you added them all together.
Yep.
It's really an amazing story when you think about it, and it's actually a history which can be simulated and well, I'd say somewhat provable. But there's always mysteries, This entire history explains why the moon is so large, after all. Okay, and it really has to do with the fact that the moon is the result of a collision with one of these bombardment era planetoids or planetesimals that struck the Earth. And that was a head-on collision. So we were just blasted. And of course, the Earth's orbit was probably altered, maybe in a good way, for all we know. Now, there's a thing I was watching several presentations by some other physicists the other day, and one of the things they said is we see the universe now, but what we don't see is all the things that happened to make it what it is now. So a lot happened that we don't know. We just see the end result. It's like going to a car crash site. We can see skid marks and we can figure out kind of what happened, where the cars came from to hit. But what if you just get there and the cars are just sitting there crushed? No tracks, no nothing. And yet you're still called upon to figure out how they came to be that way. You see what I mean? Now the task is daunting, to say the least. And that's what we're faced with the universe. There's some clues. And we use chemical compositions of some of the planets and some of the moons to help us figure this out. But that's only a theory. We don't know for sure. But there's, you can be 90% sure, 99% sure. But to me, that's not 100% sure. And no one in science will tell you they're 100% sure of anything. That's the mark of a good science person, by the way. So that's why the moon is large, as large as it is. Now, the next why is the moon as large as the sun in the sky? And I got to say right up front, there really are coincidences. And this is actually likely one of them. And now there's people in the audience going, oh, no, that's not true. Come on. Well, let me explain. Hear me out. All right. I'll tell you why. And the reason is the moon is not the same size as the sun in the sky. Okay. As the Earth moves around the sun, it's in a slightly elliptical orbit. And when the Earth is closest to the sun, the moon appears larger compared to the sun. And in an eclipse, it will completely cover the sun. When the Earth is farther from the sun at the other end of its elliptical orbit, then the moon will appear smaller than the sun. Okay? And so, I'm sorry, the Earth will appear the moon will appear larger than the sun when we're farther away, and it will cover it entirely. But when the Earth is closest to the sun, then the sun is larger, and the moon will only appear to just barely cover the sun. But when we're farther away, then the moon appears a lot smaller compared to the sun. I'm sorry.
May I jump in there for a second?
Yeah, I'm messing it up, and I'm just trying to reach another point, and I'm reading ahead, and I'm messing myself up.
Okay.
But I just want to make the final point here. Earth is an elliptical orbit, so when the Earth is going around the sun, when we're farther away from the sun is smaller in our sky, and the moon will appear to cover the sun. Okay, because the moon is still about the same distance from us. When we get close to the sun, okay, then you can see that the moon will cause what's called an annular eclipse. All right, the moon will not be able to cover the entire sun because the sun is slightly larger in our sky, and we'll have the little bit of ring of light around the sun left behind. This is something which tells us that the Earth's orbit is not circular, and it's also telling us that the moon's orbit is not flat with the sun. We don't get an eclipse every single month. All right, that's another thing. So now they say, well, the sun is 400 times further away, and the moon is 400 times larger or smaller than the sun, and it's like, the moon's 400 times smaller than the sun. It's 400 times further away, but that's not always true. And over history, the moon has been a lot closer to our planet, and it's slowly spiraling away from the Earth. All right, and that's due to interactions with our tidal bulge. That is to say, the interactions of the angular momentum, the movement of the moon around the Earth, is actually causing the Earth's day to slow down. Okay, so as this Earth day slows down over time, and orbital physics tells us what we see to be true, and that is that the moon will creep away from the Earth. It will actually leave the Earth system slowly, and is doing so at 1.5 inches or 3.82 centimeters per year, and it will eventually never cover the sun for future inhabitants. And they will wonder what we were going on about with these eclipses. See what I mean? What are you going to say, Daryl?
Oh, conservation of angular momentum.
Yeah, that's the reason why the moon is spiraling away.
Yeah.
I wanted to say it in a way that it makes sense to folks listening to.
Sure.
Yeah.
Sure.
But that's very true.
I heard it was going to orbit away too. Where will it go? Is it going to get trapped in another orbit?
Well, no, it's spiraling away slowly from the Earth, but it's only going, 3.8 centimeters per year. And you're in Canada, so I'm using the centimeters, not the inches.
Thank you.
So you can tell that, how long will it go? How long will it be before the moon is actually no longer gravitationally bound to our Earth? And that'll be longer than the sun has left to live. So we aren't going to have to worry about that. Unless we have a situation like Space 1999, the old show with Barbara Bain and Martin Landau, where they're on the moon at Moonbase Alpha. And there was this gigantic set of explosions, and the moon was propelled out of its orbit and went hurtling through the universe. And every week they came in touch with alien creatures, which at the speed they were hurtling, they should never even gotten past like Mars. So I don't know where all these aliens were hiding, but you know what? It was science fiction. It wasn't good science fiction, but it was all we had. So it was wonderful, right? And it was British, so that made it even funnier. Actually, so I really enjoyed it. So if we go back now and look at the Earth-Moon system 1.5 billion years ago, the moon was a lot closer. Our Earth day was 18 hours long. And the moon was certainly larger than the sun in our sky. All right. And it's truly coincidental at this point in our history that the moon appears similar in diameter to the sun. A few million years ago, it wasn't the case, and it was bigger. A few million years from now, and it will be smaller than the sun. So it's a changing timeline, a changing value. But at some point, the moon has to be about the same size as the sun. And it just happens that because we live now, we've noticed it. And because we're intelligent beings now, we've noticed it. But it wasn't always the case.
Okay, this is going to be a very, very basic question, and I feel kind of silly asking it, but you know how the moon is gravitationally locked to the Earth?
Yes, tidal locked, yep.
Is that the same for the planets and the sun? Are the planets kind of gravitationally locked into the sun?
Not locked, but they are gravitationally bound to the sun.
Okay.
They orbit the sun.
So
we aren't tidally locked to the sun. We don't have one.
Not tidally locked. No, bound. That's what I meant. Okay, bound.
We are gravitationally bound. Yes, gravity's holding us all to the sun, and it's our original momentum of movement when we were formed here in this solar system from the nebula, the solar nebula, that we keep moving. There's nothing to stop us. See? Now, in the early solar system...
hold on.
Yeah?
How the moon is slowly leaving the Earth's gravity. Are any of the planets in our solar system slowly leaving the Earth's gravity? Or the sun's gravity?
No, not really. I mean, there are...
It really sounds like kind of.
No, it's because I can't answer the question with a definitive, because I can't speak to all the goings-on way out in the Kuiper Belt, which is out beyond Pluto. There may be collisions of objects out there which could put them in different orbits that could take them away from our solar system. But the main planets are in a relatively stable, it's actually called a resonance with each other, so that we're not worried about any of the planets leaving the sun.
But the moon isn't stable right now, and that's why it does have the capability of moving a little bit?
No, the moon is undergoing an interaction with the Earth. Okay, the Earth and moon are both spinning. It doesn't look like the moon is spinning, but it is. It's traveling once around on its axis every time it goes around the Earth. Mm-hmm. If it didn't, it wouldn't have the same face of itself pointing at us all the time. So if you looked at just the moon over the course of a month, basically you'd see the moon spin once on its axis. And that is because it's tidally locked to the Earth. And because of that, there is an interaction with the, as Daryl said before, angular momentum, which is actually the energy of the motion associated with the rotation, right? And as the moon is tugging on the Earth, the tidal bulge on the Earth is being affected by the moon's gravity. The Earth is slowing down in its daily rate, in a very minuscule manner, because of this friction, so to speak, with the moon. And that kind of frees up the moon to actually move a little further away, because this is effectively, think of it as a closed system of Earth and moon. And so if the energy is being reduced in one component, another one gets it, right? It's orbital mechanics, basically, orbital physics. And so we're watching the moon go a little further away from the Earth every year because the Earth is losing a little bit of energy each year. See?
Yet the total energy is conserved.
Yeah, the total energy has to be the same at the end, so to speak. So therefore, somebody has to benefit, somebody has to lose. Well, the Earth's losing. Now, we're not going to end up with days that are 48 hours long, all right? But we will end up with days that are a little longer than they are now, but not in our lifetimes. It's very, very slow, Now, so at some point, we have to address some of the oddities, and this oddity actually is for the hollow moon folks, okay, who think it's a giant spacecraft, in part because it's about the same size of the sun in the sky, okay. And the view, that's a bit closed-minded, I think, because the moon has been migrating away and it'll eventually be smaller from the sun, as we pointed out. It just happens to be around the same same size that we see it now, because this is our time in the sun, so to speak, our time in history. But it hasn't always been like this. It won't always stay like this, and it isn't staying like this. So, and for those who think it's hollow because it rings like a bell, I just wanted to remind you, look up the ringing stones. In fact, if you live in Pennsylvania, you can go to Bucks County, where you can go to the Ringing Stone State Park, and they give you a hammer, and you can go out and just bang all day long on rocks that ring like bells. Now, these rocks are solid rocks, and it's because of their chemical composition, maybe the iron content in particular, that they ring like this, but they are not hollow whatsoever. So at the very least, we would have to state the fact that not all bells, quote unquote, are hollow. All right. So the moon, in fact, seismically has a somewhat molten outer core, a solid inner core, and a very, very solid mantle. So it rang like a bell, and that was the wrong word. They should have said it rang like one of the ringing stones, but then you have to explain the ringing stones. But the fact is, the moon is actually quite solid, and it's much more solid than the Earth. It's smaller. It's had time to cool. So basically, we know that the moon is solid. So I don't think that the folks that believe in the hollow moon theory really have any way to combat that, other to just say, well, NASA lies, because that's sort of like the catchphrase, right? NASA's always lying. But the fact is, it's not NASA that's telling us this. Okay, we've had other spacecraft from other countries go up there and tell us this. So now they have to extend the quote unquote conspiracy to all nations of the Earth that have visited the moon: the Chinese, the Japanese, the Americans, okay, and the other folks that have actually participated, the ESA, European Space Agency. They're going to have to extend this conspiracy to everyone. Everyone has to be keeping the secret. You see, and it just sort of degrades very quickly from there to, one of these arguments where you just can't, you can't win because they just say, yeah, that's wrong, that's a lie. NASA lies. Yeah, but it's not NASA. What about Jackson?
It's like flat earthers.
It's like, yeah, like Japanese space agencies, that they're lying too. The ESA, the European Space Agency, they're lying too. You know, what about the German astronomers who actually made quite a contribution? How about the Chinese? Who are on the dark side right now? The dark side, the far side of the moon. There is no dark side. Okay. What about that? Why are they keeping the secret too? I will say this though. They found a massive cave on the moon, and this is true. There has been a 50-kilometer long cave that's been found on the moon, and you can see it from the orbiter. It was, I think, a Japanese orbiter that actually saw it. Might have been Celine. Celine might have seen this, and looks like a hole, and it leads to what we know of as a lava tube, a remnant of where lava once ran in a conduit under the moon, and as it ran through, it eventually coats the walls with a hard molten rock that ends up cooling, and then when the lava runs through it now and empties out, you're left with this hollow tube, and there's one that's 50 kilometers long. It's a perfect space in which to put a base.
Yep.
It's your space base. Have you heard about that one, Daryl?
Oh, yeah. Prime candidates for lunar colonies are in lava tubes.
That's right.
Got to go in and seal some cracks, and, hey, you got a ready-made domicile there.
Yeah, that's true. But you know what? We're going to talk more about that, and we'll actually take on our last part of this, and the phone lines will be open by the time we come back. I'm Mark D'Antonio for Sky Tour Radio with Daryl and Amanda. We shall be back in just a few, so hang on.
I'm getting older and noticing that my body just doesn't work as well as it used to. So I like to try to keep fit as possible by hitting the gym a few times a week. And recently I started having a nagging bicep pain and I couldn't lift weights. When I was complaining about it to a friend of mine, he told me about Angioprim. He said chelation helps remove toxins, heavy metals, and cholesterol in the veins and arteries that may cause blockages. After 1 week of taking Angioprim, the pain was gone, and I'm back in the gym full strength. Find out more. Go to angioprim.com. ANGIOPRIM.com. Scientific research proves the active ingredient in Angioprim helps promote cardiovascular health. Talk to a trained consultant, or you can call Angioprim toll-free at 877-882-8221. That's 877-882-7221. This statement has not been evaluated by the Food and Drug Administration. This product is not intended to diagnose, treat, cure, or prevent any disease.
Every 2 seconds, someone needs blood. Whether it's a natural disaster or one single child suffering from illness, the American Red Cross stands ready to supply blood when it's most needed. But blood is a perishable product. Therefore, it must continuously be replenished. You can safely donate blood every 56 days. The need is constant and patients are waiting. Call your American Red Cross at 1-800-GIVE-LIFE to schedule your life-saving appointment. Please give blood today. Patients are depending on you.
Folks, this is very important information. What's to be said about CBD? AncientLifeOil.com. Our CBD is made from hemp and has 0.003 THC, which means this wonderful product won't get you high, no matter what amount you take. What does CBD do for the body? My hands are tied, but you can Google CBD benefits and be astounded. When you're finished reading, you'll want to log on to AncientLifeOil.com. That's AncientLifeOil.com. and purchase. Life is good when you feel good. People are tired of pain. People are asking for non-GMO organic products to help them with you fill in the blank. Legal in 49 states, and again, our CBD is made from hemp. Ancient Life Oil is about helping people one by one by one. If you wonder how good the product is, the CEO takes it every day without miss. AncientLifeOil.com. That's AncientLifeOil.com. Have a great day.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now. The Paranormal Radio app, free in Google Play and the iOS App Store.
You listen to us, and we listen to you. And so does the CIA. KGRARadio.com.
Hey guys, welcome back to Sky Tour Radio. This is Mark D'Antonio, of course, with Amanda and Daryl. Or is it Daryl and Amanda? Well, it's Demanda or Emerald. I don't know. They're a combination. They're sort of a combo.
Meryl is the Pokemon.
No way.
Meryl.
Yeah.
Yeah.
Meryl. Okay, that's not a Meryl, right? Oh, a Meryl. A Meryl. Okay.
Yeah.
Ay. And you think you're tired, And next week, starting Tuesday, I fly to Los Angeles, and I'm not back till Friday. I have to tape a Discovery Channel show on Wednesday, a Travel Channel show on Thursday, and then I'm back on Friday. It's going to be, it's going to be kind of a whirlwind. Then the following week, it's off to Norway. I've been trying to learn Norwegian, but it's I'm good with languages, but it's a little bit hard. If you want to say thank you in Norwegian, you just say it's tusen takk, 1,000 thanks. Tusen takk. Yeah.
I remember when I was in Germany, I tried really hard. I really did, and I tried ordering in German at a restaurant one night. And the waiter, he wound up leaning over me, real tall, skinny guy. He goes, "Pardon me, sir, do you speak English?" So I just talked English after that.
That's what I hear it is like there. And I'm not doing my talks in Norwegian, of course. But it'll be really interesting. I mean, that what I'm going to talk about in Norway is something very kind of outside my, kind of outside the science in a sense, because it's talking about where does science go in the face of the unexplained things we see. And it'll discuss the weird encounters, if you call it that I seem to have had. And how do you explain the things that happened to me over time? I think you and Amanda have heard the dog story where I saw this semi-visible creature walking in my shop when I was working on a movie prop, actually. It was 3 p.m, right? You remember the story, Amanda?
I'm actually just looking for it. I did a little video to it, didn't I? I'm sure I did. Your ghost dog? I know the story well. I think I have a video for it. Let me look.
Yeah, and so what happened was when I was in the in my studio working on a model for this movie we're doing, I was all excited. I was wide awake. And this thing comes walking into my shop, and I basically was looking right at it, and it's sort of like water without the shine. It was sort of semi-transparent. And I stared at it, and the way it was bouncing along in this little gate, it looked to me like it's some kind of a dog. And I blinked my eyes. I was shaking my head, saying, "What the heck is that?" It's not like I was up all night and I'm tired. I was wide awake and very refreshed. And I stared at it for a couple of minutes, and then I got up and I walked over to it, and I'm looking down at it. And it's like it's not going away. And I'm thinking, okay, is there something medically wrong? And is something happening medically? And I stepped where it was. That was the thing that determined what was everything else to happen. And I stepped on it. And I couldn't have predicted what happened next. I mean, I'm a science guy. This stuff doesn't happen to me. So I stepped on it. And when I stepped on it, it seemed to register that I stepped on it. And it got up and it ran out of my shop. I'm just an astronomer. I don't know about these. I don't do these things. And it ripped my foot out from under me. It took my foot right out from under me, and it flipped me up into the air. I upended totally, and I landed. My right shoulder hit my workbench, which resulted in a frozen shoulder. I had to go to the hospital for that. Hit my head in the concrete floor, and I was in pain. I was dazed. I heard ringing in my ears, and I got up and I was totally excited. I couldn't believe what just happened. I was like amazed, and so I started to think that maybe I was witnessing something that was a new science, basically something that had yet to be discovered. And could it have been a medical event? Well, maybe, but my foot being yanked out from under me, it felt like a repulsive magnetic field in the back of my heel pushing my foot out from under me. It was really weird. I mean, there's no question it happened. It wasn't a dream. It happened to me. I had to get treated for it. And so the bottom line was I had no idea what this was. And then I started to read some papers. I can't remember which science teams did these papers, but they were talking about parallel universes and how the missing mass question in our universe, which may have been solved, there's some question. The missing mass in our universe led to thinking that maybe the Big Bang was one of several bangs that occurred. So sort of a mediocre bang, okay? And there was other bangs that occurred, and they were all parallel universes, perhaps all coincident in the same place, but alternate dimensions, up to 10 dimensions, like in string theory, right? So that said, when I started to think about that, I looked for more papers on this parallel universe possibility, and it turns out that there's other papers out there. And now some of the top physicists and astrophysicists are talking about the possibility that the Big Bang was one of several, and that maybe there are other coincident universes, and that we're all sort of in the same place. Now, what does this mean? Does it mean that when people say they see ghosts, they're actually seeing parallel universe bleed through, a parallel universe intersect? I mean, that's the term I coined, the parallel universe intersect, about, I don't know, 3 years ago. And I thought maybe if it's real, then, we can't deny that that's a possibility. And science used to deny all those things. But now I'm really, really heartened by the open minds that I'm seeing in science now. Science used to be the place of arrogance and stuffy old men, okay? Well, now it is a place of men and women equally partnered up and sharing ideas and learning new things with open minds. I can't believe the change in my own lifetime, all right? And I've watched the arrogance melt away in the face of the unknowns that we've had to face. And I'm really heartened by it. I really am. And so does this mean that I experienced a parallel universe intersection? Does it mean that this dog thing that I stepped on when it ran out of the room, that was considered rudimentary communication with a parallel universe? I don't know. It could have just been a medical event which caused my foot to fly out. But in order to find out the answer, I actually went to the doctor. I had neurological studies done. And those of you who attend SkyTour live stream, you've seen there was one stream where I actually had basically this gauze helmet on with a bunch of electrodes that had been planted under my brain, and it was hanging off the back of my head. Well, and people said, "Oh, you're Neo from the Matrix." Yeah, well, joke, maybe, but I was trying to get to the bottom of if it was a brain thing. I wanted to find out if it was, because that's what the doctors thought, because that's what they know. So I went through all the motions. Whenever I saw an event, I clicked on it. I said, okay, I see an event. Something's happening. I see something over there. And the results, my brain was acting normally. There was nothing wrong with my brain. So that was something that I thought was very fascinating. So to this day, I have no idea what it was. But that's one of the things I'm going to talk about in Norway. I'm going to go through one of these, that's just one of those several, and talk about these experiences that I cannot explain. And speaking of things,
I hope we get to see footage of that. I don't know if you can stream out from Norway to your channel or not. Maybe set that up, but that'd be really interesting to see, I think.
We're gonna actually try to do some of that actually.
Yeah.
And it depends on the Wi-Fi. I don't know how Norway is with Wi-Fi. Apparently, it's the same in big cities because we're going to be in Oslo and Bergen. So I'll let you know. But, and this, again, I'm not weird. Okay? I'm a science guy, and this stuff doesn't happen to me until it does. Then I have to deal with it. I don't know what to do with it. I'm just telling you the honest truth. And speaking of knowing what to do with it, we have a caller. And I'd like to take the caller. So let's bring the caller on. Hello, caller. You're on the air. This is Mark with Amanda and Daryl. How are you?
Hey, how you doing, Mark? And hello, Amanda, and hello to Daryl.
Hi, Ronald. How are you?
Doing good, thank you. I had a question. about the moon's orbit and how it is going to affect planet Earth if it, or as it does go farther away. But also, you had showed a moon on Jupiter last night on your tour, and I was asking you what the distance was to Jupiter, and then for that one moon that we were looking at. You remember that one?
Oh, you mean the distance to Jupiter from that moon?
Yeah, from, what was it, BB or whatever?
Oh, what Ronald's talking about, folks, is last night on Sky Tour Livestream, we were doing that tour of the universe, basically starting with the solar system, and I took us to Jupiter and did a sort of a grand tour looking at some of the moons. And one of the moons we saw was Thebe, which was a little tiny asteroid, essentially, that's surrounding Jupiter. It's one of the little asteroids around Jupiter. So I think, is that the one you're talking about?
Yeah.
Ronald?
Yeah. Yeah.
Okay. I think that well, I know actually Thebe orbits Jupiter at around 220,000 kilometers from Jupiter, about 3 times the radius of Jupiter away. And as such, it's still very tiny. But you also look at Jupiter and you notice that Jupiter has rings, just like Uranus and just like Neptune, and Saturn, of course. So, we see things that we haven't ever seen before. And so I like to try and pick out the things we've never seen and go see them directly as if we were there. So that's why I was captaining a spaceship last night.
Nice. That was a nice program you shared last night.
I'm glad you enjoyed it. We'll do more, because it makes a beautiful. I worked out the bugs with it because there were some bugs with it the last time I tried it. But
on the attraction of the moon, on the attraction of our moon orbit, though, it controls or has an effect on our tides, our oceans.
Yes.
What kind of an effect will that have as the moon slips away, or as the orbit gets kind of odd compared to what it is now? Right now, it controls a lot of different things on our planet. Could the motion of the moon be causing some of the Earth's actions, like earthquakes and things like that, or more volcano activity, or would that have any effect on Earth? And then I'll listen to it on the show. Thank you for taking the call, and thank you, Bill, for having the phone line.
Thank you so much for the call.
Thanks, Ronald.
Yeah, bye.
Bye.
So to answer the question from Ronald, the moon does affect the tides, of course, on the Earth with its gravitational force. And as the moon moves away, we could, in fact, expect and calculate that there will be a ever so slightly different value to the tidal ranges that we see here on the Earth. And but it won't make sense to try and calculate those any time within a human lifetime. We'd have to calculate them thousands of years in the future to see a subtle difference. It's not going to change drastically in a short period of time, because at literally 3.8 centimeters or 1.5 inches a year, we need thousands of years before we could even get a significant figure value for what that change would be.
May I ask, this might put a curveball on Ronald's question. If the moon did not exist, we would still experience tides from Earth's gravitational interaction with the sun, correct?
That is correct.
Yeah.
It would be about half the amount.
Okay.
So tides won't ever go away. That's the thing. So here's the question, and this is a really interesting question, because the question has been posed to me in the past. What would happen if there was no moon? Would we still have been able to arise here as an intelligent species, or even as life, land-based life. Well, during the course of our history, life began in the oceans, and there were tides in the oceans. But the way that we moved onto the land, in theory, and in what seems to be the fossil record, is through the repeated exposure to the air in the tide pools. And so some of the creatures became able to utilize the oxygen in the air as opposed to the oxygen in the water. And the oxygen in the air was something that is a very different mechanism to extract. It requires a different mechanism to extract. But there were creatures that evolved that mechanism. And who knows how many dead ends evolutionarily there were. But at one point, one was naturally selected as one that could survive in the tide pools. And so there were probably some form of fish that could survive for a few hours at a time while the tide was out. Because as soon as the tide's gone out, it's actually already starting, it's coming back in almost immediately. It doesn't stay out and stay out and stay out. It just reverses on a rhythmic cycle. Okay. And so the bottom line is that this is what led to us leaving the oceans, which is, by the way, why you have some salinity in your bodies. You are carrying around the vestigial ocean with you all the time. It's not as saline as the ocean, but that's why we evolved to have the need for sodium chloride, salt, is because we originated in the ocean. So when the creatures left the ocean, they left the ocean based on the fact that the tide pools were forming. So people said, well, without the moon, we wouldn't get tide pools. And my first comment was, actually, yes, we would. We would still get tide pools, but about half the strength as the moon. All right. So
we have a question from chat, actually.
Okay.
It's from Charles, and he wants to know, I'm assuming in this hypothetical situation where we don't have a moon, he wants to know, would the Earth still be spinning in 10-hour days? And I kind of question him on that. What do you mean 10-hour days? And he said 2 billion years ago or so, the days were 10 hours instead of 24.
Well,
and all that spin energy was stolen by the moon.
That is correct. And he's right about that. The spin energy was stolen by the moon, and it's actually very perceptive of Charles.
Charles is awesome.
Yeah, he's actually a very smart guy. You know, Ronald asks good questions. Charles has wonderful insights, and I'll tell you, as I said, our KGRA listeners are the smartest audience on the earth.
They really are.
They really are, and he's right. You know, what would happen to our day? Well, there will be interactions with other bodies over time, over billions of years. So our day probably would change anyway through to relative, interactions. But it wouldn't be a 24-hour day at this point. We would actually probably still be maybe 11 or 12 hours, maybe 13, don't know. And there is this relates to our last. Actually, this is a very good segue to our last lunar mystery that we want to talk about, and that's the 5-degree inclination of the moon's orbit. Why don't we see eclipses every single month? Why is the moon elevated like that? Why is it have an inclination of, it's actually 5.145 degrees? Why is it that the orbit is inclined? And it's been perplexing astronomers for a long time. But there's a recent paper that came out that takes into account possible other types of gravitational interactions that are likely to have occurred in the early solar system. And when the early bombardment era occurred and the late bombardment era, these large objects were propelled into the inner solar system by Jupiter and by other interactions, collisions, and so forth. And some of them struck the Earth, but not all of them did. And the Earth-Moon system, when it had formed, we still had the bombardment going on. And one of those large objects could have come through the solar system from farther out into the asteroid belt and then either been ejected by the sun or burned up into the sun or went farther out into another orbit where it was captured by something else. We will never know, okay? And it's called a possibility of a non-collisional interaction. It means that it's markedly different from a collision. In this scenario, Jupiter may have dislodged many asteroids, broke up planetesimals out there in the early asteroid belt, and it's likely that one of these that did hit the Earth was that Mars-sized planetesimal we talked about earlier. But later on, a larger body could have come through the Earth-Moon system, and the Earth, being more massive, wasn't affected as much, but the Moon was drawn up into a different orbit. And now we actually demonstrated that very thing in Sky Tour live stream on when we played with Universe Sandbox 2. And this was something, when you play with gravity is a strange thing because it starts interacting with you a long way before you think it does. And then when it finally gets closer to you, it's a lot stronger. And as it passes, it gets weaker, but its damage is done. It pulls things around. And so the Moon was pulled up in its orbit to the current position, to that 5-degree inclination. And then over some millions of years, it's stabilized into its 5-degree inclination that it has today. So, when we look around the solar system, the evidence of these massive impacts is on every single body out there that actually has a surface. We can't tell how many objects impacted Jupiter. We've seen at least one. Comet Shoemaker-Levy struck the surface of Jupiter and the cloud tops and left these black scars. I watched them myself with my own telescope. I watched them. You did too, right? Yeah.
You betcha.
It was beautiful.
It was.
It's amazing to see Jupiter with like black spots on it. It was a wow, look at that. But on the Moon and other bodies in our solar system, we actually see with hard surfaces, everything is cratered. This was an area with lots and lots and lots of debris, and that is why we are at this point in our time probably fairly lucky. But it's not over yet. I mean, clearly there's still objects out there. The Earth is struck by tons of material every single year. The Chelyabinsk. Yeah, that's true. But the Chelyabinsk meteor that struck over in Russia was, I think, 16 feet in diameter. Right, 16 feet, a large object.
I thought I heard somewhere they said it was about the size of a bus.
Okay, rough order of magnitude, similar. Maybe somewhere. Maybe it was the short bus. I don't know. But the bottom line is that and so we've seen those, and occasionally they do damage. The other one that was, of course, huge was the Tunguska explosion. That was an air burst just like Chelyabinsk, and it was disastrous because it flattened forests for miles and miles around underneath the explosion area. Big trees too, 12 inches in diameter, just like crushed like matchsticks. We didn't see that like that until the Mount St. Helens eruption, and that pyroclastic flow and that cloud just literally blew down entire forests. So the forces are stupendous, and so the Earth has been a victim of these impacts all throughout its history, and the Moon is the mute sentinel to these impacts because we can still see them. Most of these impacts on the Earth have all but been eroded away, but there's still some more recent ones that are visible on the Earth. And if you want to see them, you can go to Google Earth and download Earth impacts. It's called an overlay, and you open up Google Earth, the application you can download for free. Open up the Earth impacts overlay, and then go around the world and look at all the craters. And you do see craters. You see the craters. Meteor crater in Arizona, of course, is one of them. But you see craters up in China. You see craters in Europe. You see craters that now have cities over them. But you can see the ruins of the craters up near Amanda. Okay, there is a large reservoir that is a ancient meteor impact crater.
Manicouagan?
That's right. Yep.
Mark, can I jump in here?
You're on the show. Go for it.
Okay. While we're talking about planetary impacts and stuff, it has always struck me as odd that the Earth and Mars not only have similar axial inclinations, like the 23.5 degrees in our case, and not only that, they have within a half an hour the same length of day. That has to be simple coincidence, doesn't it? I mean, both cases, I assume, had to be from, impacts. But I just always found it striking that we have the same tilt and we have pretty much the same length of day.
Yeah, I mean...
And I wondered if that says anything deeper right there. I doubt it, but...
Well, our axial tilt also is related to our moon. And over time, I read a paper about this where the Earth's inclination was affected in part by our moon as well. So as far as Mars, yes, I would say that currently we're looking at basically it's a cosmic coincidence. And people don't like to believe in coincidence, but you know what? There really are coincidences. You know, and it's not it's something you may not want to believe, but unfortunately, they really are coincidental. There's no reason why the Earth and Sun are. I'm sorry, the Moon and the Sun are the same size in the sky because it wasn't always the case.
Yes.
The Moon was a lot larger in the sky than the Sun. Then the Moon will eventually be a lot smaller than the Sun.
I was just always fascinated by that idea.
Yeah.
You know,
so was I.
I don't see how they could be related, but like you said, I'm not much for coincidence myself.
Yeah.
Here we go.
Unfortunately, that's about all we have time for, though, Daryl and Amanda. I'm sorry we're going to have to go. Ladies and gentlemen, and everybody listening, I want to thank you for spending time with us here on Sky Tour Radio on KGRAradio.com. We wish you adieu. We won't sing our song anymore or hum it, whatever. It's a beautiful song. And we'll see you next week at 8 o'clock Eastern Time on KGRAradio.com. And remember, keep looking up.
Except while you're driving.
Good night, everybody.